Hi, my name is Nolan Kovach. I'm here to talk about ordered mesoporous carbon nanomaterials and their use for F-element separations, as well as a phenomena that we've discovered along the way. We make these materials through a nanocasting technique, starting with mesoporous silicon nanoparticles. After a multi-step process with following pore infiltration and carbonization, we then etch these templates away to give us ordered mesoporous carbon. Following this, we've then added either Tadga or a combination of Tadga and 2-octanol, shown here on the left. Tadga is a known F-element extractant, and 2-octanol is thought to act as a wetting agent or dispersant for the system. We see from transmission electron microscopy, these particles exhibit a pretty roughly hexagonal morphology, as well as a well-defined ordered pore structure. We see from nitrogen sorption analysis that first, ordered mesoporous carbon in itself possesses a very high surface area, pore volume, and has an average pore-to-pore diameter centered around 5.2 nanometers. After adding Tadga, or a combination of Tadga and 2-octanol, the surface area of these materials drastically decreases, as well as their pore volume. Their average pore-to-pore diameter, however, is only decreased slightly. However, this still permits contact of analytes within the pores of these materials. Small angle X-ray scattering has shown the potential phenomenon of crystallization as shown by these diffraction peaks here, shown at high Q. We then looked at the same material using X-ray diffraction and saw the prominence of a few peaks shown here at around 10, 15, and 16.5 degrees. To get a very good phase identification of these peaks and confirm whether this is europium crystallizing or not, we would need to perform phase ID experiments which require modified and longer X-ray diffraction scans. In addition to this, we look to utilizing different carbon functionalization techniques to putting extractants on the surface, such as this hydroxyethylene diamine triacetate complex right here. Another direction that we look to use these OMC materials is incorporating heteroatoms such as boron or nitrogen into their framework to then enable their use as heterogeneous catalysts using things such as frustrated Lewis pairs.